हेलो स्टूडेंट्स, जय हिंद। आप लोग कैसे हैं? आई होप यू ऑल आर very fine and staying healthy, fit and fine, right? So let's begin our session today. In today's lecture, we'll be discussing some very interesting numericals. These are actually some selected questions which are based on equations of motion, right? We have studied the three equations of motion. So these are the questions which we will be using those three equations, right? So let's start with the first question. First question is, a train is running at a constant acceleration. So it is the case of uniformly accelerated motion. The two ends of the train pass a pole with velocities v1 and v2. Find the velocity with which the middle point of the train passes the same pole. Now look students, suppose this is the pole and this is the train, right? This is the front end and this is the back end. So when the front end, this end crosses the pole, its velocity is v1. And when the last end of the train crosses the same pole, its velocity is given to be v2. And the train is in uniformly accelerated motion. What we are supposed to do is, we are supposed to determine the velocity of the midpoint of the train when it crosses the same pole, right? So let me depict the entire situation with the help of a diagram. Suppose this is the front end of the train and this is the last compartment of the train. And this is suppose the midpoint of the train, right? Represented by M. Let us consider this to be A, this to be B, and let us consider this to be C. And this is the pole. This is suppose the pole, right? So when this front end crosses this pole, it possesses velocity of v1. It is given. When the last compartment crosses the same pole, its velocity is given to be v2. When this midpoint of the train crosses the same pole, then suppose its velocity is v. This is what we are supposed to find. And v1, v2 are given. So obviously, we need to find an expression for v in terms of v1 and v2. This is the midpoint. Suppose the length of the train be x. Then this being midpoint, this distance would be x by 2. And this distance would be also x by 2. Isn't it? Now, since it is the case of a uniformly accelerated motion, we can very much make use of the equations of motion. So, consider the motion of the train from point A to C. Now look, this is very important to write this statement. A to C means A is the initial point and C is the final point. Between A and C, the body of the train has changed its velocity from v1 to v2. v1 is the initial velocity, v2 is the final velocity at point C. And during this time interval, the body has covered or the train has covered a displacement of x. Right students? So let's make use of the third equation of motion. Third equation of motion is 2as is equal to v square minus u square. Obviously this is the third equation of motion. So 2a is uniform as displacement covered from A to C, it is x. It is equal to, what is the final velocity? That is v2. What is the initial velocity? At point A, that is v1. So put this as equation number 1. Right students? Now consider motion of the train from A to B. A is the initial point, B is the final point. Now if you apply the same third equation of motion, what you get is 2a is the constant acceleration which the train possesses. S is the displacement covered between A to B. A to B, the displacement covered by the train would be x by 2. It is equal to final velocity square minus initial velocity square. Now final velocity at point B, B is the final point. Here the velocity is v. And initial velocity, that is at point A, that is v1. Right students? Now look, we need to find out the expression for v in terms of v1 and v2. So what needs to be done is, if you divided both these equations, x gets eliminated, a gets eliminated, we'll get the expression for v. So dividing 1 and 2, what you get is, first divided by second, what we get is 2ax divided by 2x by 2. divided by 2ax by 2, and over here we get v2 square minus v1 square divided by v square minus v1 square. So what we get is 2 is equal to v2 square minus v1 square divided by v square minus v1 square. So on cross multiplication we get 2v square minus twice v1 square is equal to v2 square minus v1 square. Further, on rearranging the terms, what we get is minus 2v1 square. When it is taken on the right hand side, the sign will get changed. So 2v1 square minus v1 square, that will give us plus v1 square plus v2 square. Therefore, v square is equal to v1 square plus v2 square divided by 2, which implies that the velocity of the midpoint of the train while crossing the same pole would be given by v is equal to square root of v1 square plus v2 square divided by 2. So students, this is the result, which is very, very important. Now if such questions comes in MCQ, in the competitive examinations, then in order to manage your time well, you can directly make use of this particular formula without bothering about to derive this formula, right? So in such a case, make use of this formula directly. If the velocity of the first point and the last point is known to us, and if the body is in uniformly accelerated motion, then the velocity of the central point of the body would be given by this particular formula. Right, students? Well, let's proceed with the second question then. Second question is also very, very interesting one. As I told you, these all are selected questions. Every question has some concepts involved in it. So, let's concentrate on the second one. A man on a railway platform is just 9 meters behind the entrance door of a train when the train begins to move with a constant acceleration of 2 meters per second square from rest. The man picks up a uniform speed to get into the train and he just boards the train. Find the speed he picks up. This is again a very, very interesting question, right? Suppose this is the train. This is the entrance of the train, right? And this is where the person is. So the person is at a distance of 9 meters. Students, one way of doing such questions, or one way to make such questions simple, is to depict the situation in a diagram, isn't it? That will make everything clear in your mind, right? So, man on a railway platform is just 9 meters away behind the entrance door of a train. When the train just begins to move with constant acceleration of, the train pauses a constant acceleration of 2 meters per second square from rest. So, initial velocity of the train is 0, right? The man picks up a uniform speed to get into the train and he just boards the train. He is just able to board the train. We are supposed to find out the speed he picks up, right? So what it means is, suppose this is at t equals to 0, this is at t equals to 0. Now what it means is, the train starts from rest and it accelerates with 2 meters per second square. Now, person moves with uniform speed like this. This will be the situation, right? Suppose the person is able to board the train at this position. Suppose the person is able to board the train at this particular position. So, this is at time t equals to t. So, if the person is moving uniformly with constant speed, then the distance covered by the person during time t, say with speed v, is what? It is equal to v into t. Distance is equal to, it can be considered to be x. Distance covered by the person with uniform speed v in time t is vt. Clear, students? And during this time t, the train must have covered this distance, isn't it? So the train has covered this distance. So let's find out distance covered by train in time t. Remember, train is in uniformly accelerated motion. So we can make use of this equation, s equals to ut plus half at square. So S would be equal to, this distance would be equal to U. Initially the train is at rest. Half acceleration is given to be 2 t square, right, in time t. So S would be equal to t square. So this distance covered by the train in time t would be t square. So students, diagram is clear. Again I repeat, initially this is the position of the train and the person, like this. This is the position. Now the train starts moving uniformly at a constant acceleration of 2 meters per second square. So the situation will be like this. This is where suppose the person is able to board the train, right? So in time t, the person has covered distance vt. It is in uniform motion. Uniform motion, the distance is given by speed into time. And in the same time t, the train is in uniformly accelerated motion. It has started from rest and has reached this particular point, covering a distance of t square as we have determined over here. Right, students? Now look, concentrate on this particular diagram. It's pretty clear. Vt is equal to 9 plus t square. It is pretty evident from this diagram. This distance is Vt. This distance is 9 and this is t square. So from the diagram, it is very much clear that Vt is equal to 9 plus t square, or t square minus Vt plus 9 is equal to 0. Over here, V is the uniform speed with which the person runs. Uniform speed, constant speed. So V is constant over here. T is variable. So it is a quadratic equation. So let's determine the value of T. We are already aware of the roots of a quadratic equation, isn't it? Minus B plus minus square root of B square minus 4AC divided by 2A. So minus B minus B, it will become plus B plus minus square root of discriminant B square minus B square, it will give us B square. B square minus 4AC, 4A into C. 4 coefficient of T square is 1 and it is 9, so it is 36. Divided by 2A, coefficient of T square is 1, so it will be 2. So here make use of the formula for the roots of a quadratic equation. Ax square plus bx plus c, that's the standard equation of a quadratic expression. So its root is minus b plus minus root b square minus 4ac divided by 2a, right? Now, time, it can't be negative, it has to be real. So, for t to be real, this discriminant, it has to be greater than or equal to 0. The square root of v square minus 36 is greater than or equal to 0. Or v square must be greater than or equal to 36, which implies that v must be greater than or equal to 6. Actually it is plus minus 6, but it is greater than or equal to 6, right? Now the question is, find the speed he picks up and he just boards the train. He is just able to board the train. So we are supposed to find out the minimum velocity which the person can possess so as to board the train. So therefore, v is equal to 6 meter per second. The minimum possible speed which the person can possess so as to board the train is to be considered, because he just boards the train, just is able to. So it is 6 meter per second. So I hope students you have understood the concept involved in this particular question. It's a very good one, right? So question number 2 is over. We have done question number 1, question number 2 is over. Now let's proceed to question number 3. Question number 3, we will try to solve it graphically. It will be much simpler if you indicate the situation by plotting velocity time graph. Okay, let me read the question for you. Question number 3 states that the speed of a train increases at a constant rate alpha, this is alpha, from 0 to v, and then decreases to 0 at a constant rate beta. If t is the total time elapsed, then find the expression for the maximum velocity and the distance covered by the body during that time. Right? So what you need to do is, I'll solve it using graph. This is velocity time graph. Now look, the speed of a train increases at a constant alpha from 0 to v. Initially the body is at rest and it is a constant acceleration. Uniformly accelerated motion. VT graph is a straight line. This is it, right? So over here. So rate is alpha. Alpha is the acceleration. Then decreases to 0 at a constant rate beta. Okay, it decreases to 0. Again, it decreases to 0 at a constant rate beta, right? And suppose this is the velocity which it acquires. This is v. This is v. Suppose this time is t1, this time is t2. Alpha and beta are the acceleration and the retardation respectively. So what we are supposed to find is, find the expression of the maximum velocity. This expression is to be found. This is the maximum velocity, right? At this point, the maximum velocity is to be determined, which is considered to be v. So what to do is, t is the total time elapsed. So t is given by t1 plus t2. Put this as equation number 1, right? Now what are the coordinates over here? Coordinate over here is 0, 0. Over here the coordinate is t1 and v. And over here the coordinates are t2 plus t1. This is the total time, t1 plus t2, which is t and 0. These are the coordinates of these 3 points. Now students, we all are aware the slope of the velocity time graph, that will give us acceleration. Therefore, alpha, this is the acceleration. It will give us the slope, right? So slope is y2 minus y1 divided by x2 minus x1. So v minus 0 divided by t1 minus 0, which implies that t1 is equal to v by alpha. Put this as equation number 2. Slope of velocity time graph, that will give us acceleration. Similarly, let's consider this one. This is the case of retardation. So it has to be assigned negative sign. Slope of this line. So these are the 2 coordinates. This is x1, y1. This can be considered to be x2, y2. So y2 minus y1 divided by x2 minus x1. So it is 0 minus v divided by t2 plus t1 minus t1. So what do you get is minus v by t2. So which implies that minus minus get cancelled. So we get t2 is equal to v by beta. Put this as equation number 3, right? Now we need to express the answer in terms of alpha and beta. So what to do is substitute this value of t1 and t2 in equation 1. So from 1, 2 and 3 we get t is equal to v by alpha plus v by beta. V can be taken as common, 1 by alpha plus 1 by beta, or t is equal to v, alpha beta will be LCM, and over here beta plus alpha. So what will be the velocity, maximum velocity? It will be alpha beta divided by alpha plus beta multiplied by t. This is the expression for the maximum velocity of the body which it will possess. So this is done. Second one, displacement covered. Students, look, this has been repeated numerous times. The slope of VT graph, that will give us acceleration. The area under VT graph, that will give us displacement covered by the body. So, displacement covered by the body during this time interval will be equal to area of this portion. So, it will be equal to area of this triangle. Now, area of triangle is half base into altitude. That is half V into T. So, substitute this value of V over here. So, what do you get is alpha beta divided by alpha plus beta multiplied by T square. So, this will be the displacement covered by the body. So, we are over with the second part as well. So, such questions, if solved graphically, it is much more easier and much more convincing, right? So, we are over with the first 3 questions. Fourth one is somewhat related to third one, right? So, let's try the fourth question. Again, we'll try to make use of the same technique. We'll try to solve it graphically only. Fourth question is, the speed of a train increases at a constant rate alpha from 0 to v and then remains constant for an interval. and finally decreases to 0 at a constant rate beta. If s is the total distance described, show that total time taken is t equals to s by v plus v by 2 bracket 1 by alpha plus 1 by beta. So, let us draw the situation, right? Velocity time graph. The speed of a train increases at a constant rate alpha from 0 to v. Constant rate. So it should be a straight line. Rate is alpha. Suppose this is the final velocity required. Then it remains constant for an interval. It remains constant. So it is the case of uniform motion, right? Velocity remains constant during this interval of time. And then it again retards and its velocity finally becomes 0 at a constant rate beta. This is beta. S is the total displacement covered, right? And we are supposed to prove that the total time taken during the entire journey would be given by that. So what we do is, let's divide it into 3 parts. Suppose this is t1. This interval of time during which the body is in uniform motion is t2. And the time during which the body retards is t3. This is t3. Total time is t. So first one is t equals to t1 plus t2 plus t3. Put this as equation number 1. No doubt regarding this, right? Now let's substitute the coordinates over here. Here the coordinate is 0, 0. Here the coordinate would be t1 and v. Here the coordinates would be t1 plus t2 and v. Here the coordinates would be t1 plus t2 plus t3 and velocity is 0. Right? These are the coordinates. So students, again as was done in the previous question, the slope of velocity time graph will give us acceleration, isn't it? So in the first case, what to do is alpha, it would be y2 minus y1 divided by x2 minus x1. So t1 it would be equal to v by alpha. Put this as equation number 2. Similarly, this is the retardation, negative slope. So minus retardation means acceleration is to be assigned negative sign. So beta it would be given by y2 minus y1 divided by x2 minus x1. So it is 0 minus v divided by t1 plus t2 plus t3 minus t1 plus t2. So that will give us minus v by t3, which implies that minus minus get cancelled. t3 would be equal to v by beta. Fine students, these are the equations which we are obtaining by using the concept that slope of velocity time graph will give us acceleration of the body. Now look, S is also given, it's the total distance described during the entire time interval. And students, area under VT graph, that gives the displacement cover. Now that's the key point. So displacement cover would be given by area of this trapezium. This is in the shape of a trapezium. So area of trapezium. And the formula for the area of trapezium is half multiplied by sum of the parallel sides multiplied by the distance between them, perpendicular distance between them. So half multiplied by sum of the parallel sides. Sum of the parallel sides. This is t. This is t. These are the two parallel sides. This is t plus this side. This side. It is t2. Half multiplied by sum of the parallel sides multiplied by the distance between them. This is the height. The distance between these two parallel sides is v. This is it. So what to do is take out the value of t2 from here. So 2s is equal to 2s by v. V can be taken over here by cross multiplication. So it will be t plus t2. Or t2 is equal to, I think, 2s by v minus t. Is it okay, students? So 2s by v is equal to t plus t2, or t2 would be equal to 2s by v minus t. Put this as equation 4. Now using first, second, third and fourth, we should get the expression, right? Let's do it. So let's make use of the equations 1, 2 and 3. Actually, there are 4 equations. So let's substitute the value of t1, t2, t3 over here. So therefore, from first, what we get is t equals to t1. t1 is v by alpha plus t2. P2 is 2s by v minus p plus P3. P3 is v by beta. Okay, minus t. If it comes over here, the sign will get changed, so we will get twice t is equal to 2s by v plus v can be taken as common, 1 by alpha plus 1 by beta. Dividing 4 by 2, what we get is, we will divide the entire expression by 2. So what we get is s by v plus v by 2, 1 by alpha plus 1 by beta. So this is the expression for the total time taken by the body. So this is what we were supposed to prove. So we are done with question number 4 as well. So students, I hope these questions are very, very important. So I sincerely hope that you will learn the concepts involved in such questions. Right, students? There are some very, very interesting and very good questions. Okay, let's try the 5th question. This is a different question and requiring some basic concepts. Okay, 5th one is, a balloon is moving upwards with a speed of, this is a balloon suppose. There is a balloon and it is moving upwards with a speed of 5 meter per second, right? When it is at a height of 100 meter, okay, it is given to be at a height of 100 meter. A packet is dropped from it. A packet is dropped from it, right? So what is the velocity of the packet when it strikes the ground? When this packet strikes the ground, then what will be its velocity? So students, I recommend, please do such diagram, right? It will make the question much more simpler. You will be able to understand the question that much more easily. And once question is understood, 50% question is itself solved, right? Believe me. So here the concept is, students, look, this is stationary. My hand is stationary over here. Now if a body is dropped from here, if it is dropped from here, so its initial velocity would be 0, right? Its initial velocity would be 0 in that case. Now what to do is, if I raise my hand like this and then I make this body to fall from my raising hand, then what will happen is its initial velocity won't be 0. It will possess initially the same speed as that of the speed of my raising hand, but since it is falling in the opposite direction, its direction of motion is different as compared to the direction of motion of my hand. So its initial velocity would be of the same magnitude but would be assigned negative sign. Clear, students? So in this case, the initial velocity of the packet which is dropped from the raising balloon would be not 0, will not be 5 meter per second, it will be actually minus 5 meter per second because it will drop like this. Its direction of motion is opposite to the direction of motion of the balloon. Clear, students? If I raise my hand downward and then I allow this pen to fall downwards, then both are having the same direction of motion. So in that case, its initial velocity will be same as that of this with positive sign. I hope you have understood the concept. So initial velocity of this package or of this packet is to be considered as minus 5 meter per second. That's the key. This is the key point. In case of a free fall from a stationary object, the initial velocity would be 0. But the packet is dropped from a balloon which is raising. So its initial velocity would be minus 5 meter per second. Its magnitude would be same as that of the velocity of the balloon, but its direction of motion being opposite, negative sign is to be assigned. So this is the most important point over here. Now the question becomes very simple. So U is given, S is known to us, and G, acceleration due to gravity. Ball is falling, the packet is falling downwards, so it is plus 10 meter per second square. So what to do is, using this we can find out the time by using second equation of motion. So second equation of motion is S equals to ut plus half at square for the packet. So S is 100. 100 is the distance which is covered by the packet, right, before it strikes the ground. Initial velocity is not 0, it is minus 5. T plus half, A is 10 t square. So let's solve it. 100 is equal to minus 5t plus 5p square. This is 2. So dividing throughout by, so what we get is, dividing throughout by 5, we get 20 is equal to minus 5 plus t square. So it can be written as t square minus t minus 20 is equal to 0. So this is a quadratic equation. We can solve it either by using the formula for finding its roots, minus b plus minus root b square minus 4ac divided by 2a. That is one method. The other method is by splitting the middle term, right? So let's try to split the middle term. So it can be written as minus 5t plus 4t minus 20 is equal to 0, which implies that t, it can be taken as common. So t minus 5 plus 4, t minus 5 is equal to 0. So t plus 4 multiplied by t minus 5 is equal to 0, which implies that either t is equal to minus 4 seconds or t equals to 5 seconds. Time can't be negative, so avoid this result. So we get t equals to 5 seconds. So students, what we have calculated is the time taken by the packet to cover this distance of 100 meter or to reach the ground. Now our main objective is to determine the speed with which the packet strikes the ground. So it is remaining in the air for 5 seconds, right? It is covering a distance of 100 meter. Its initial velocity is known to us. So we are supposed to find out the velocity with which it strikes the ground. So u is known, t is known, a is given to be 10 meter per second square, and we need to find out the final velocity. So let's make use of velocity time relationship, which is the first equation of motion. So using first equation of motion, what we get is v is equal to u plus at. Therefore, initial velocity is minus 5, a is 10 plus 10, that's coming downward, and time, just now we have evaluated it, it's 5 seconds. So v would be equal to minus 5 plus 50. So it is equal to 45 meter per second. So students, this is the velocity with which the packet will strike the ground, isn't it? So we are done with all the 5 questions. I hope these questions, after solving these questions, I mean, it must excite you. It must create interest in your mind regarding solving such questions which are based on our daily life experiences, isn't it? So students, again, I must reaffirm or I must repeat this term that do practice as many numericals as you can. Numericals, students, are the integral part of physics, right? Once you are clear with the theoretical portion, you need to concentrate on numericals based on the learned topics. Clear? It is then you can gain in confidence. Right, students? So I hope this session will give you immense boost or confidence in tackling such numericals. So I wish you all the very, very best, and please stay safe, remain indoors, and do take very good care of yourself. Thank you, students.